Why go to the deep sea? The more strange the animal looks, the more. Is it because they can't be seen in the deep sea? Don't care about your image. Just grow up casually. For example, the anglerfish has a light organ on its head. There are also people with mouths bigger than their bodies who can swallow people, as if every species in the deep sea. All of these have broken the conventional design of life on Earth. Looks like an alien creature, actually. This is mainly due to the harsh living environment in the deep sea. Not only is it difficult for sunlight to penetrate here, the water pressure is even great, enough to crush steel into pieces. So only in this harsh environment, only then can we breed strange-looking deep-sea species. First, in a dark environment, animals' visual systems will be completely reshaped. The area, about 201 kilometers underwater. Only the pale blue of the sea can be seen, and red. Colored creatures here have a natural ability to be invisible. For example, the vampire octopus takes advantage of this characteristic. Purify your skin towards deep red, combined with weak sunlight. Make the body feel like it is merged with the seawater. This is true whether you are hunting or avoiding predators. Even vampire octopuses can do it with ease. If it's a water area where even light can hardly penetrate, then deep-sea animals must be strengthened. Your own visual system. For example, the eyes of a giant squid. It evolved to the size of a football. This effectively focuses one of the few rays of light in the deep sea, so that you can see more clearly. If you reach a deeper abyss, even the last ray of sunlight disappeared. Then the eyes of deep-sea animals will lose their function. Some even have their eyes degenerated directly, hunting prey solely by hearing and perception. Some, they have evolved hunting organs that go beyond vision. For example, the light source on top of your head. He can imitate a lighthouse in a dark environment. This attracts prey to fall into the trap. And in the ultra-deep huddle zone below 6 kilometers, there's no light here except even the pressure has reached an alarming level. The pressure at 1 kilometer underwater. It's roughly equivalent to 100 elephants stepping on your body. At the deepest point of the Mariana Trench, the pressure, this is enough to easily crush a tank into scrap metal. So in order to cope with this super strong water pressure, deep sea animals have evolved extraordinary body structure. In most animals, no hard bone structure. For example, a soft body like the deep sea octopus, to help it balance internal and external pressure. Scientists have discovered a new type of uranium in the deep sea 8 kilometers underwater. A super deep sea snailfish was discovered. Its skeleton has completely degenerated. The body is almost transparent. It looks like a sticky liquid. However, only this soft body structure to withstand the water pressure of 8 kilometers underwater. In addition, due to the lack of sunlight in the deep sea area, so there is no way for photosynthesis to occur. The main source of energy here, it's snowflake rain from the upper layer. These dense white dots, they are all small plankton in the upper layer, and fragments of decaying animal carcasses. Of course, with just these leftovers, it certainly can't satisfy the appetite of deep sea animals. So they also evolved extreme predation strategy. The devouring barbarian not only has a bloody mouth, there is also one that can be like a balloon-like stomach. This will help it swallow prey that is several times larger than itself. In the deep sea where food appears randomly, the ability to overeat is a necessity for survival. They can, when food appears, a hearty meal. Then I survived a year, because deep sea species also have slower metabolisms. So you don't have to worry about food during this period. Actually, the reason why deep sea species give people a sense of weirdness, this is because humans have an instinctive fear of unfamiliar environments. They don't have land creatures, symmetrical body structure. Instead, it appears as if it is irradiated, distortion after invasion. These structural features are often beyond our understanding of biological appearance. Plus, as terrestrial creatures, we know very little about the deep sea conditions. So unknown, this also strengthens the label of deep sea species as weird. The deep sea is a world of poverty. As the depth increases, biomass dropped sharply, forcing deep sea creatures adapting to the environment in various strange ways. Normally, they rely on marine snow as a food source, that is, fecal particles falling from the sea surface, and dead organic debris. These sea areas are also protected and function. Organisms can only survive on these residues. However, in the deep sea, some area, but it can carry out primary production through another mechanism. This is chemical synthesis. These are the chemosynthetic oases of the deep sea. They are on Earth. Few sources of life energy, not sunshine, but the place of the Earth itself. Before we officially start exploring, fix the infinite blanket to generate organic matter. But the difference lies in the source of energy. In some areas of the deep sea, primary production relies on chemical energy instead of solar energy, but this can only happen in certain seabed environments. There are chemicals released into the seawater. This environment mainly includes two types: hot night vents and cold spring. The former was not discovered until 1977. Then, scientists are near the Galapagos Islands. Seafloor spreading inspection. They discovered a hidden world, completely changed our understanding of how life on Earth exists. Afterwards, scientists discover hundreds of vent fields worldwide, typically located 2 kilometers below the seabed, even deeper, distributed at plate convergence boundaries or seafloor spreading zones. This is the area where the sheep shell is opening. East Pacific Ridge City, one of the areas with dense thermal vents. Due to the rapid expansion, there are many vent areas on the ridge, tens of kilometers apart. In contrast, the ultimate expansion rate of the Atlantic is slower. Vent areas may be hundreds of kilometers apart. Formation of vents. It's due to the tectonic plates breaking apart. Hot magma closer to the seafloor. The upper structure of the seabed is very porous. Cold ocean waters penetrate deep into the Earth's interior. It is heated there and dissolves a large amount of minerals from the surrounding rocks. Then this mineral-rich hot liquid ejected from the seabed at extremely high speed. Temperatures can exceed 400 degrees Celsius. When hydrothermal fluids mix with cold seawater, dissolved minerals will precipitate quickly, forming a smoke-like jet, and accumulate into tall smoke structures on the seabed. There are several types of hot leaf nozzles. Depends on the mineral composition of the vent fluid. Black smoky onion releases the hottest and darkest spray, forming smoke onions up to 50 meters high. Contains a lot of sulfide. Precipitate rapidly upon contact with cold seawater. Black smoke form. In contrast, white smoke contains calcium and silicon. Some vents appear as flashes of water, forming a unique landscape. Although the temperature inside the nozzle can reach 400 degrees Celsius, but between the hot night and the surrounding seawater, there is a very steep temperature gradient. Within a range of approximately 10 cm, the temperature can be increased from more than 300 degrees. The temperature dropped to around 2 degrees Celsius. Most vent animals living in an area with lower temperature, but some prokaryotic microorganisms, including bone fungi and bacteria, can survive temperatures up to 122 degrees Celsius. Here, they are synthesized through a variety of chemical pathways, obtaining energy. The method depends on the conditions of the microenvironment and the presence of chemical substances. Usually they use hydrogen sulfide, or the energy stored in chemical alkalis in methane, converts water and carbon dioxide into glucose. This chemical synthesis brings about primary productivity, create dense animal gathering areas. These nutrients forms the basis of a complex food web, supporting an ecosystem composed of specialized organisms. They are oases of life in the deep sea. To understand the importance of these ecosystems, just compare them to the normal deep sea environment. Make a comparison. On the abyssal plain, although life exists, but the distribution is sparse, animals must be separated from each other to get enough ocean caves to survive. In the nozzle system, the smoke is covered with rusty red snails. Clusters of deep straits run through it. There are also large white crab competing for habitat on the rocks. Surprisingly, these are of various types. Species with large biomass all rely on the same resource source: chemical synthesis. Microorganisms, that is to say, significant interspecies competition exists in the vent area. That is, different species have the same competition for resources. Generally, this competition may lead to the extinction of some species. Those species with poor adaptability may not have access to sufficient resources, eventually eliminated by more dominant species. In a stable ecosystem, no two species can completely occupy the same ecological niche. Long-term coexistence. This is called the competitive exclusion principle. But if competition doesn't lead to extinction, species often diverge. This phenomenon is called resource differentiation. That is, species with overlapping ecological niches will evolve different ways of adapting. This will reduce direct competition between them to achieve coexistence. This is the hot night vent. Reasons for ecosystem stability. Although crab, like insects and shrimps, they are pursuing similar resources, but they develop their own different ways to obtain. For example, lobsters and clam will scrape the microbial spots around the stone vent. We can also find deep-sea ibex. Such a lawyer, they hang, feeds on free-floating microorganisms. Snowman cultivates filamentous bacteria on his own body. This reduces their competition for space with other species. These bacteria act like symbiotic partners, attached to the surface of the crab. Let the crab move with them. In contrast, giant tube worms are sessile creatures that cannot move. Their competitive advantage lies in able to establish symbiotic relationship with bacteria. Tube worms store bacteria in their internal structure. It is equivalent to keeping them in captivity to obtain nutrition from them. Tube worms absorb hydrogen sulfide from vent fluids, other chemical substances, provide raw materials for bacteria. The bacteria synthesize the carbon needed by the tube worms. The study also believed these bacteria, protected by living inside tube worms, protected from predators such as crabs and prawn. Another alkali-growing organism at the vent makes Pang Bay like a worm. It is similar to the yeti crab. Also cultivate bacterial colonies on the body surface, but it has better high-temperature tolerance, can live on vent structures, higher temperature locations. They live in a U-shaped pipe. Ambient temperature can be up to 80 degrees Celsius. So just like the creatures in the middle zone, these animals are in the vent area, showing a zonal distribution phenomenon. This is due to the temperature, titrate, and different microorganisms. The distribution of species, in a sense. Although tube worms and crabs live in the same vent, in the system, however, they are geographically isolated due to their respective adaptability. So far, the organisms we mentioned are all primary consumers, but in the nozzle system, there are also predators at higher trophic levels. For example, octopus. It's one of the top predators of deep-sea vents. There is also a white fish feeder that uses tube worms. Feed on river shrimp. Some deep-sea fish usually live in continental slope area. They also come to the vent area to hunt and lay eggs again. They use the volcanic heat released by the vents, accelerate embryonic development, shorten the incubation period, which originally lasted several years. Due to the zoning phenomenon in the vent area, we are in the distance. Farther outlying area, you'll find more lawyers and predators, such as the oil vine and predatory anemone. They don't quite adapt to being near the vents. Rich in chemicals, low cultivation environment, but still able to survive at a distance. On the outer submarine plains, we can also find non-vent organisms. Their numbers are often greater than other deep-sea areas, more. This is because even if you are hundreds of meters away from the vent, these creatures can still use the spray, some organic matter exported from the mouth area. From a global perspective, geographic isolation between different vent areas, they also create their own unique endemic species groups. For example, in the Pacific Ocean, we often see a large number of giant tube worms. In some areas at the end of the Atlantic, they don't exist at all. Instead, the dominant species is shrimp. Scientists have now discovered the hot night vents. More than 590 species of animals were discovered. These biological clocks, most of them only exist in this environment. Their living height, nozzle-dependent chemical synthesis, ecosystem, discovery of deep-sea thermal night vents. There is another important meaning. These vents have extremely high energy and rich chemical nutrients are called chemical gardens. This got scientists thinking, is it possible that life exists here alone? Although there is no conclusion yet, but there is a lot of evidence to support this conjecture. First, some of the microorganisms living in the vents are thermophilic microorganisms. That is, microorganisms that like high temperatures, considered to be the most primitive life on Earth. One of the forms. Furthermore, many of the basic chemical building blocks of life, such as amino acids and nucleotides, can be found in vent environments. This shows that under the conditions of the primitive Earth, the premise of life, it may be that the abundant dioxygen in the vents, carbon dioxide and hydrogen, synthesize these complex organic molecules. Ocean is hot night vent, fostering a unique ecosystem. There are both highly specialized organisms. There are also simple microbial communities. Together they form islands of life in the deep sea. These originally barren deep sea areas, it becomes vibrant due to the presence of the vents, reveals to us the true conditions for the existence of life. However, the hot spring, not the only deep sea chemosynthetic oasis.